to the webinar. And thank you for participating in our webinar about TrackSwitch360 solution. I will be your host, and the speakers today will be Kristen and Nils. But before we get started, I will go through a few housekeeping. This session will be recorded, and I will share it with you afterwards. You can write questions during the presentation in the Q&A, which is located at the top, and we will answer all the questions at the end. It's also possible for you to ask your questions at the end. You can just raise your hand and then I will unmute you. If you have questions that we cannot answer straight away, we will get back to you after the webinar so that all questions will be answered. I will give the presentation to Kristen.
Thank you very much, Christina. Good morning, warm welcome from me as well to all of you who are listening in. I would just like to give you a quick introduction to our company. As you know, today's session is about switch monitoring, but just want to tell you how we actually started 10 years ago. We got a request, or the owners got a request from an infrastructure owner, the one who manages the bridge and tunnel combination between Funen and Zealand in Denmark, where they asked for a wireless digital monitoring system to help them monitor the tracks. And so this was the beginning, and since then we have learned how to apply many other types of sensors. Of course, we need sensors to help our clients, but I just want to say and underscore that what we are really all about is the software that we have developed over time to where it is today, and that is really what gives our clients insights into their infrastructure. We operate in 10 different countries today on the European continent. It should be more very soon. And with that, I will hand over to Nils, who will tell you more about what you really want to hear, which is about switch monitoring.
Thank you, Kristen, and also welcome to you from my side. I will I'll now take over the control of the presentation and give you a technical dive into the TrackSwitch360 series, which we have developed. And maybe some of you already know, but for decades, monitoring of the switch points by using current of the point machine has been used as a technology for this monitoring, and by this also try to derive different failure patterns and so on. But still, there are many switch failures and downtime caused by failing switches. So in close collaboration with infrastructure owners and also some turnout manufacturers, we have developed a series of solutions for monitoring more of the physical behavior to provide better insight, and the scope is also pointed to the operators and maintainers, and of course to reduce downtime and prevent failures. TrackSwitch series is individual monitoring solutions which can be combined together, but also combined and also fusions with the data from other sources, like for example current monitoring solutions and others. And I will now guide you through the different types of solutions we have, and I hope that you get an insight. And if you have, as Christina said in the beginning, any questions, please just follow up by the end of this presentation. First of all, we have developed what we call tongue gap monitoring solutions, which is monitoring the gap between the stock rail and the switch rail. Of course, the signaling system takes care of all the security, and most of our solutions here are pointed in the area of switches that may not fail, and if they fail, they will stop the traffic, and there will be a lot of traffic disruptions. So our solutions are primarily pointed at in areas where they have most critical switches, like in train stations and other bottlenecks. But the tongue gap here actually monitors the physical blades between the stock wheel and the switch wheel. And by this, we can also derive more data and information besides the gap, and I'll get back to this in a while. Next to this, we have what we call switch monitoring, which is not only the gap, but the actual movement of the blades from left to right and right to left. So we have the software have the view of the behavior. Is there any misbehavior that can be caused by bad lubrication and rollers and so on? So this is something that leads to information to the maintainers, and where they have the possibility to derive different failure patterns. On the other hand, we also have what we call TrackSwitch health solution. This is two different types of sensors. We deploy one in the area of the frog area, and one typical in the beginning of the turnout near the switching area. The reason for monitoring the vibration in these areas is primarily to monitor if there are any changes in the voids, meaning the deflection when the train is passing, because the rails are fixed in these positions either by the point machine or in the area of the frog, and if the deflection is getting bigger and bigger due to poor ballast, it will impact and create fatigue failures of the different components like the frog, and also the blades and the switching parts. So this is why we have are deploying these sensors in these areas. As said in the beginning, we also fusion data. In this case, we have this. This is a picture of the blade movement, the switching, and we can fusion this with the current measurements, which is typical such a scenario here. Maybe you have seen such a graph before. But by combining these two, we not only have the monitoring of the current of the point machine, but also the physical movement of the blades. And by using this information, it is better to detect the specific failures and create more value for the maintainers and the people that are working and trying to find root causes, and also to fix the failures. We combine this with something we call climate monitoring solutions, which is we have sensors that are monitoring landslides, some drainage efficiency, meaning when it's raining, where is the water flowing, is there any flooding, and also temperature monitoring of the rail. And last but not least, also we have cases where we have actually sensors deployed below the ballast in the sub-ballast to monitor the moisture in the sub-ballast, which also is used to detect or monitor the efficiency of the failures, but also how the water is floating around the track. So all this is what we call TrackSwitch360 series. I will now go to a little deeper understanding of the tongue gap monitoring. And here we focus on what we call short-term, kind of a warning system, and more longer-term monitoring, which is focused for the maintainers and maintenance planning. Of course, for the more short-term, it is, well, are we able to operate the switch as we expect, and if not, what is actually wrong, and can we get a notification? And here, in combination with information from the signaling system, we have the possibility to detect, is this a signaling failure, or is this a real mechanical failure, like is there a blockage? We have seen operation patterns where they're trying to throw the switch to one side, and the signaling system do not report that it is interlocked, and then they try again and again and again, and suddenly it turns that now it is in control, but maybe the rail actually have been in the right position, and then it is of course a signaling failure, not a real point machine failure or mechanical failure. For the maintenance part, if there are some change in the actual distance between the gap, meaning the gap between the stock rail and the switch rail, we will be able to see this because we monitor continuously and not periodically, like it's normal in the according to the legislation. We also introduced something we call tongue misalignment. This is a phenomenon that we have seen where the point machine leaves the blade in a position, and first time the wheel from the train passes after a switch movement, it actually moves the blade, and this is something we have seen can be caused by loosening bolts and also other failures. Yes, I will now go. The second component or the monitoring component is blade movement, and here it is a sensor deployed next to the slide chair or the roller. It monitors also the daily operation, and it's easy to log in and see if there's a failure. Is this caused by some movement behavior that has changed, or there has been a warning signal from the system? Seen from a maintenance point of view, there are more information from this system, because it also have the possibility to monitor if there are any anomalies in the movement caused by bad lubricated slide chair, or if there are rollers, if they are not aligned as it should be. We have also detected that the detection rod that actually is the rod that is connected to the signaling system, if this is out of adjustment, then you will not have the information towards the signaling system, but even though you still have the blade in the right position, and this is where you can use this information to make a better root cause detection and faster failure fixing. The third monitoring part is as mentioned before, the trackbed health, where we monitor the movement of the entire sleepers when the train is passing. We monitor both the movement, the actual level of movement, but also the frequency, which is also possible to detect if the wheel hits the frog when it's passing the crossing section. This is where the operation can get an immediate insight and get a notification that there has been a wheel hit or a wheel impact. For the maintenance, it's more about, well, is the ballast moving, or the rail moving more than expected and above the limits, then we have the possibility to use the historical data combined with an algorithm that can show when it's time to TAM, but also the effectiveness of the track adjustment. Because if you have a big deflection, you make a track adjustment, and then maybe 14 days after, you discover, or the software discover, that you are in the same situation as you were before the track adjustment, then you have another problem, because then it's not very efficient to make this tampering. So these in combination is something where we have the possibility to inform both the operators and also the maintainers. I will now move to a case here in Denmark, where we have deployed 5 systems in a light rail, here the scope is to reduce manual inspections. In Denmark, we are forced to do manual inspections every bi-weekly, making a visual inspection of the gap between stock rail and switch rail. Having this information digitalized, this can be avoided. And the goal is here to reduce manual inspection and also have the possibility, if there are any failures, to act in advance. We have installed a set of 5 systems. 4 of them are only monitoring of the gap, and the last one is both the gap and also the movement of the blades, which can provide more information as efficient. Because we are well, one thing is to record data and let the software do the analysis. Another thing is actually to inform and have the dialogue with customers, and we have monthly meetings with the infrastructure owner to discuss the data, combine this and also align this with how the maintenance people sees the actual situation. Because one thing is to have the data, the other part is also to understand the data, and this is where this dialogue comes into place. So we are in close collaboration with the infrastructure owner, because it's also new for them. And in this case, they already monitor the current of the point machine, in this case, first Alpine system. And combining this with our information is also where it creates even better value. One of the use cases that we have got of information from this actual case here is that before they actually had our system, they frequently had some issues with some of the switches. They moved it from left to right, for example, and they didn't get this control signal feedback. Then they tried again and again, and sometimes they got into control, and everything was okay, and they could pass the train. But they didn't actually know, is this a signaling issue, or is this a real issue with the blades, that they are not in the right position? And by having installed our system, they now have the possibility not only to get the signaling feedback, which is the safety system, but also have a monitoring solution that can actually detect if there's any anomalies in the operation, if the blade is not in the right position, and they use this before they have to send people on site. Imagine this is in the city of the city, and there's a lot of traffic. They do not have the possibility to get access to the track. And having this better information, they have the better possibility to use the time and also to send the right crew and plan the maintenance activities. So this is some of the benefits that they have seen by having this installed. Yes. Another case is from Luxembourg. We have deployed 4 systems in the center of Luxembourg, monitoring not only standard switches but also 2 double slip switches. They had, in this case, also very critical switches. If they do not operate the switches normally, it will stop all traffic from the station towards the country in France, Belgium, and also to Germany. So this is quite critical switches. Here they already have current monitoring of the point machines, but they would also like to have a better insight of the mechanical behavior, and also use the software to create automatically root cause detection for being able to better plan. And there are today approximately 600 trains every day. So having half an hour stop, it creates a lot of traffic jam and unhappy customers. And by that, of course, also limited access to the track. We deployed both gap monitoring, also this void detection, as mentioned before, but also the switch movement. And we did combine this with the existing current monitoring system they had. So we got information from the current monitoring system, and our analysis in the software were able to use this information also to detect, is this a point machine failure, is this a mechanical failure, or is this something else? So this created some high value for the people. Also here we had a close collaboration. So also every month we had meetings with the in this case the maintenance department, so they could understand better what is being measured and also how this is combined with the existing current measurement that they have deployed for their systems and the infrastructure. Yes. So what is it that we provide? Well, we all the manual inspection is of course periodic. You do it on a schedule based, and you have the information from the people on site, quite skilled people often, but different people. You get the information on a spreadsheet or in a ERP system, and it is something that is monitored by people on site. By the sensors, you get digitalized information. Of course, you need to transfer this information into knowledge, and also to transfer this into, well, what does this data actually means? But this is this information that you create right now. Using this and create software on top of this is where we come into play. And by the software, we use the historical data. We combine this with other information, like mentioned before, and we can also share this with the infrastructure owner. So we also push data towards other customers or the customers, so they can share, they can use this and enhance the data with their own and create even better information. So this is where we come into play, and by saying this, I will now turn into a live demo of the software with the case from the light rail in Aarhus, where we are allowed to show you some information. I will now share another screen, so 2 seconds. See if I can do this. I hope you all have this picture here. This is the live demo of the software, our digital service platform, TrackSwitch360. Here we have what we call an asset overview. So we have the different assets, the 5 turnouts that we are monitoring. We have the overview of the area, and also if there are any failures right now. Here we have the possibility to get an overview. Yellow means a warning, green is everything is okay, and so on. As said before, we are monitoring both the gap monitor, but also switch monitoring. Here we have the picture or the map of the position of the monitoring system. This is next to the headquarters. The headquarters is in this area here, and here we have a parking lot of these trains. So you must imagine that they come from here, go into the parking lot to the service area, and then they go back again. So this is how they use this switch in this area here. We also monitor the temperature of the rail in this area. And I will now go into the asset page. So every single here we have the asset overview, and every single asset has its own page. And I will now expand this. So what we see here is the overview. Here we have the live data from the asset, and down here we have what we call a forecast lens. This is where we have the possibility to use our software to detect or create what we call a baseline, which is the normal behavior of the switch. And if in this case the color change, it's called a heat map, then there is something wrong. In the part called or the movement from right to left, everything is blue, and only maybe minor green. When it's blue, everything is okay. When it turns green, it deviates a little bit, and if it turns yellow, it deviates or they exceed the baseline calculations. So in this case, everything is okay. The white part here is actually a session where where the software creates a learning period. Every single line shows a movement. So this is one event moving from right to left. And this is a 1 year monitoring period that you're seeing here. In the left to right, we see that there are some deviations, and it turns out that it turns into yellow. The software detects this and they create a warning. So the infrastructure owner then log into the system, see, well, what is wrong? Is there something we need to do immediately, or is there something we can do over time? What I will now show you here is I'll go a little bit deeper into the system and show you just very briefly the raw data of the movement. So this is the raw data, and what we see here is that we have one rail, one blade, which is in the closed position. The opposite is the open position, and then the operator moves the blade or throws the blade for the opposite direction from straight to divergent, and the closing rail opens, and the opposite goes for the open rail close. The reason for the yellow marking that you saw before is because the movement is outside the limit of the baseline. The baseline is the dotted line you see here, and also the light blue. So here it actually uses the system to see is there anything wrong. In this case, nothing especially is wrong. The behavior is more or less as it should be. We have many situations where this movement is not a straight line. It's very buckling due to bad lubrication, depending on in which part of the movement we see this buckling is also due to rollers that are not aligned, or if there are any snow or something like this also in the situation. If there's a blockage, of course, it will not reach its endpoint, and the signaling system will not make a successfully control signal, but we will then be able to see that it will not end, and maybe it will stop 1 or 10 millimeters before it gets into the position, and by that it is easy to detect a blockage and so on. So this is the raw data you see, and this is very rarely that the infrastructure owner goes into this, because this is, of course, maybe only for nerds, but it is more to show you that it is possible to have the overview and go deeper and deeper and deeper into understanding the actual situation. So this is how the system works. Then I will briefly touch base on something we call tongue misalignment, and I will now stop sharing my screen, and I will move to another screen 2 seconds to show you this phenomenon. So if you imagine that you have the blade in a position close to the stock rail, then you have this situation here. The gap between the stock rail and the switch rail is, of course, typically 0 millimeter, and it should be 0 millimeter. The limit is typically 3 millimeter, and by that there will not be an interlock signal, and everything is according to the safety signal is okay. But what we have discovered is that the blade sometimes, or the point machine sometimes leaves the blade in an odd position after a movement. So you should now see this blue line here. This is the position in the left gap. So here the blade are in the left side, and the gap between the stock rail and the switch rail is approximately 0 millimeter. And everything is okay. Then the rail moves to the opposite side, and the point machine actually leaves the blade in a minus position. And of course, it cannot be minus because you do not move the stock rail. But the blade actually tilts a bit. So there's a bit tilting here, and then the first train passes, and it now moves the rail towards 0 again, and then it moves to the left side, sorry, and then it leaves again in a tilting position. And here we have discovered, because the software, of course, detects this as an anomaly, and we have the discussion with the light rail infrastructure owner, and they discovered that there was actually a failure in the tongue part. There was a loose bolt, And I will now show you over time, because this is of course not a single scenario. This is something that adds up over time. Let's see if I can do this. So here we have the two different scenarios, again in blue and in orange, as shown before. Here the left side is quite stable. Everything is approximately around the zero position. But here we see on the right-hand side that this is actually the first where the point machine leaves the blade, and then it turns up to zero again, and then it turns down to minus, and in this case, minus 2.5 millimeter. So there's a quite huge tilt here. And then there was a maintenance part here, and again over here. This is something that might be difficult to explain, but seen from a maintenance point of view, they had some severe issues with this point machine. With the turnout, and it shows that this was due to some mechanical failures, and the system in this case here was able to detect that there were some anomalies, and by using this data to detect this, they were able to fix the failure. And this is also where not only gap monitoring monitors the gap between the stock rail and switch rail, but also monitors and detects different other failures that might not be able to be seen due to normal maintenance procedures. So this is some added benefit that can be provided by a system like this. Yes, now I will stop sharing, and I will hand over the word to Christina.
Yes, I think we've come to the last slide. Let's see here. So we have come to the Q&A part. If any of you have any questions, you are welcome to write in the Q&A session, or you can just raise your hand if you have any questions, and then I will unmute you. Let me just say thank you for participating again. And of course, if you come up with any questions afterwards, you're also welcome to reach out to any of us. Yes. So let's see if there are any questions. I will give it a few minutes, or else this was what we have planned for today.
You, of course, always welcome to reach out to us and to ask questions, and we will be more than happy to set up a meeting to talk also how we can support customers with monitoring system, both for TrackSwitch but also for TrackSwitch360 solutions. I think Mahmoud asked here, how much time does it take to install the system? Well, for the tongue gap monitor, it takes approximately 15 minutes. So installing the system is not something that takes time. Of course, you need to have a safeguard. You need to have a planned interruption, or you can do it in your night hours, but it takes approximately 15 minutes to install this.
I think that was Roland's question, but I think
I will
unmute you, Mahmoud, just a second, and then you can ask your question. I have allowed.
Yeah.
Yes, perfect.
Thank you very much. You hear me?
Yes.
Thank you very much, Niels. Thank you very much for the interesting presentation. My question is not directly to the switches, but about the combination with other modules. I mean, I know that you have other services like buckling detection, flooding detection. I mean, how it is combined with the other modules, and what about the dashboarding? I mean, was the data you showed us was the streaming data? in the
Yeah, the
presentation?
data the data
Live
you just
data?
showed, yeah, the data you just showed or you just saw now in the live demo is real data that is streamed right now. So this is from it's real data. So they are streaming right now, and this is of course it's since it's a monitoring system, we have the possibility. It is of course a secure system, but we have the possibility to share or allowed to share the data for you. But otherwise, it's of course not possible to share the data. But as again, it is it's live data. Regarding your other questions, we can combine this also with normal. In this case, we have focus on the switches. We have the possibility also to add or to have another asset view where we have some speedometers. We had this thing in the last webinar. We also showed this, and here we can combine this for say line measurements. But be aware, our focus is on hotspots. We do not have a full line. If you have a 3 kilometer or 50 kilometer of rail, then we divide it into pieces of assets and then show the different parts of the assets. If this answers your question, Mahmoud.
Yeah, I mean, exactly. I mean, because you cannot monitor the whole network, of course. I mean,
No.
yeah.
And typically also you get the overview, but the different maintainers, they have their more local responsibility. So in this case, we for example in contracting areas, we could have, or in the last webinar we showed where Wienerlinien and also ÖBB, it was the same spot, but they have their different dashboards because they only had responsibility for their own, and they also only would subscribe for warnings for their own responsibility.
Okay, thank you.
You're welcome.
And then I see we have one more question from Roland. It's in the chat.
Yeah, 2 seconds. Well, he says here, yeah, how do you make sure the communication between the sensors and the IT system remains permanently live? Is there a dedicated communication channel necessary? We have different kind of systems that communicate towards our system. In overall, we rely on the telephone communication infrastructure, depending on which customer. Sometimes they would like to provide their own SIM cards, which is encrypted in their business, but in overall, you're right. We rely on the telephone infrastructure communication structure. However, the software or the system we have continuously monitor if there are any interruption in this. So if we expect to have data every minute or every half minute or every hour, and we do not get it, not only for an asset but also from individual sensors, then the system will react on this and make a warning, and then we have the possibility to act based on this. But also be in mind here that that since this is not a safety system, if there are interruption, of course we will be able to to run the train because this is she divided into two areas. The train operation and everything related to this is of course for the signaling system and so on. This is a monitoring system. So if you have an interruption in the telephone communication system, then well, no harm is done. But of course, it is very important that you act based on reliable data and also on data that is the newest data. I hope this answered your question, Roland. I can add here that the monitoring system, of course, when we talking real-time data, it can be every minute, but for the maintenance part, it is more adding up a lot of data. So here, sometimes data only need to be present every hour or every half a day and so on. Yes.
I think those were the questions. If there are no last-minute questions, I again want to say thank you for your time.
I think Roland maybe
yeah,
have a
Perfect.
question.
Yes, thank you.
Thank you.
Have a good day, everyone.
Have a good day.
Thank you for listening.